Good morning, and welcome to day 2 of our Signal Innovation Showcase series. I'm George Seifers, Editor-in-Chief of Signal Magazine. Our first speaker of the day is Eric Singleton, Vice President of Cyber Operations with Cycurion. Eric, come on up.
No worries. Hey, good morning. Good morning. I know it's an early morning, but I appreciate everyone showing up bright and early to attend this session. My name is Eric Singleton, again, Vice President of Cyber Operations for Cycurion Incorporated. We're a business, a full end-to-end cyber company located in Tysons Corner, Virginia, in the DMV. And I'll be talking to you about our ARCS platform. It's a platform as a service, and then again, the active cyber defense and deception platform. One of the key things that I want to talk about today is protecting your digital assets. In this very complex threat landscape, it's not enough just to be in a passive environment. You have to stay active. So here's some of the challenges and the problems. The threat actors are getting more and more sophisticated. They're coming at you hard and fast using AI tools. So in the past, when you do your risk assessment, you're looking at it as if, hey, the person is not that savvy. But AI has changed all of that. You can pick that stuff up. You can throw it on, throw it out there, and then all of a sudden, you have a lot of people that don't know a lot, but has some very sophisticated attacks. So what we've done with these evolving threat vectors is that we use AI as the solution. And I'll get into that a little bit later on. Our multi-layered active defense approach allows for the threat actors to engage with our platform before it gets into your infrastructure. So all of the white noise is all filtered out before it hits your actual infrastructure. So that provides a degree of confidence that normal infrastructures that they don't have. So we intercept, we analyze, and act before it hits your infrastructure. How is this done? ARCS operates as a reverse proxy. So with that being said, anything that's publicly facing, all of that infrastructure, when it comes in, it interacts with our platform and on our interfaces, and is acting as a hardened intermediary. It inspects all incoming traffic, and then it says, hey, is this a good bot, a bad bot, good actor, bad actor, and then it allows it to come in. And how does it do this? Additionally, we have that geo-gate protection. So we can cut off entire countries through our platform. And that filter allows you to have that protection against nation states. If it's not supposed to be there, it's not there, it doesn't get in. So again, you can filter by geography, but you can also get really, really granular. This is the WAF layer, so it does real-time traffic inspection. Does dynamic filtering on malicious payloads, and it allows for, threat actors to reveal themselves to the infrastructure prior to getting into your infrastructure. So we do this in a number of different ways. One of our proprietary parts of our system is that we have a bot hunter. And that bot hunter engine allows it to, again, inspect and watch and see if there are good bots and bad bots. And it differentiates between them. Additionally, our system is built to have a dynamic block list. By that I mean we have over 13 million trusted known threats that are in our system, and it continuously builds on that and adds that and allows us to block additional issues. So dynamically learning the environment, but it has a baseline of over 13 million known threats across it. And then the third part is our AI-powered behavioral analysis. Again, it learns the traffic, it learns your environment, it can tell between the good deviations and the bad, and then it can also detect lateral movement or prevent lateral movement across your infrastructure. And what this does is, if you have capture in your particular environment, it'll trigger that, which allows your infrastructure to work as usual with those capture challenges. And then if not, it'll automatically block that, and then you go on as business as usual. So some of the things that I want to, before closing, I want to key in on here is that as this platform as a service aligns with your particular infrastructure, it creates that wall around your infrastructure. Again, threat actors will interface with the ARCS platform, allowing your infrastructure to run as usual or as intended. It's unlike traditional firewalls and static firewalls because ARCS is adaptive. It adapts to the ever-changing landscape that comes and is always coming and threatening your environment. One of the biggest things that we're going to do is, what I want to make sure I say today, is that it lowers the false positives. So much white noise out there that your analyst is getting totally hammered watching the screen. This strips all of that away and allows your infrastructure to continue to be hardened, and it reduces that SOC fatigue. And that's my presentation for the day. Thank you all. The 12 minutes. Okay. I'll take any questions. Yes.
Thanks very much for the presentation. So you mentioned it's a wrapper. So how is it deployed? Like you would deploy it outside your perimeter security, and then it would be an environment that you would point your perimeter security apparatus to, and then all traffic would flow through your environment and then be routed to wherever wherever our network was.
Sure. It's two different ways you can do it. You can do it on-prem, where you can take a virtual machine, put our platform into that environment, and then it will sit between your firewall and your infrastructure. So it'll do that traffic inspection. We also have a cloud version, which allows us to virtually deploy it in the cloud, AWS, Azure, all the FedRAMP environments, and then we just reroute the traffic through that to allow for inspection. Great question. Yes.
Sorry, I had to step out for a second. I don't know if you covered this. I'm curious about the blocking of a country.
Sure.
And any potential unintended consequences of that. Like, blocking something that is good out of that company.
Sure.
Or country.
Out of that country. Great question. So again, you can turn on the blocking for a whole country, but if you see that activity, you can actually turn on that particular IP or IP block and say if it's coming from a particular company or organization that you do work with in there, you can add that to it, and it'll allow you that traffic to come in.
Quick follow-up on that. I mean, is that dynamic? Is that how,
Sure.
in the business that we are in, sometimes seconds matter, sometimes senior folks want it now or don't understand why it takes so long, that kind of thing.
Sure. When we go to onboard, we actually look at your client history. So the other thing it does, it has two modes. It has a detect mode and a protect mode. So the first, when we deploy it, we just learn the environment. And this allows it to say, okay, you know, this particular organization, it's flagged, and it's good. So before we go into protect mode, we actually accept all of that traffic into it. And again, the analysts will be looking at it, and if that happens, we can turn it on immediately.
The slides talk a little bit about deception. Can you talk about what that feature is and how that works?
Sure. So when I talk about deception, it's not like a traditional honeypot or anything like that. It's just thinking that you're acting with the actual environment. So you're throwing a number of botnets at it, and it's constantly hammering, but it's not affecting the actual infrastructure itself. So when the threat actors think that they're getting in, it's actually capturing that information in our AI and allowing us to feed it to other tools in order for it to say, okay, and we work in concert with to say, hey, we capture those TTPs, and then we use those TTPs to further make our platform a little bit smarter on that. So again, you're looking like you're interfacing with the actual infrastructure, but all the while, we're capturing that information. Good question. Any other questions? Gentleman in the back, questions? I appreciate it. All right. Thank you for your time.
Thank you, Eric, for a great presentation. Thank you all for being here. Our next presentation will be at 10:20 on modernized AI and data-centric security. Thank you.